225,000 lines of Rust, 1,880 merged pull requests, a release every single day, and the project is less than 5 months old. This is Buzz from Block, and I want to lead with what's good about it because quite a lot is. It's a team workspace you can host yourself, and the idea underneath it is one I hadn't seen done properly before. An AI agent isn't a bot with an API token bolted on the side. It's a member with its own key, its own rooms, and its own name on everything it does. That is a genuinely good idea, and the engineering under it is better than most. So let's start there, and then I'll show you the 3 things I'd want fixed. Before any of the code, the idea. Think about a group chat at work. You type a message, it goes into some company's database and it sits there. If that company edited it or quietly deleted it, you would have no way to tell. You trust them. That's the deal, and mostly it's fine. Buzz changes one thing. Every message is signed the way you'd sign your name on a note before pinning it to a board. Anyone can check the signature. And instead of the messages sitting in a database that someone can reach into, they are entries in a shared logbook where every entry is signed and the order is recorded. Swap a page and the signature stops matching. That's it. That's the whole idea, which leads to the part they actually care about. If a message is just a signed entry, then an AI agent doesn't need special plumbing to take part. Give it its own signature, and it's a member. It joins rooms it posts, it opens code reviews, and every single thing it does carries its own name rather than hiding behind a shared robot account. If it misbehaves, you can see exactly what it did. That's the pitch. The rest of this is whether the pitch survives contact with the code. So does it hold up? I started where anyone self-hosting would. The health check the deployment guide tells you to run. It passes. And this is a client connecting to the same relay at the same address 1 second later. 404. The relay is fine. It's the guide that's wrong. And the reason is genuinely interesting because the thing causing it is one of the better security decisions in the codebase. One piece of vocabulary before the code because you'll see it everywhere in this repo. That signed logbook idea isn't theirs. It's an open protocol called Nostr, built for exactly this. Signed events, relays that store them, keys as identity. Buzz is a Nostr relay wearing a workspace. And before any criticism, this is a well-run project. 1,880 merged pull requests against 350 open, a ratio of more than 5 to 1. 46 contributors, with the busiest at under a third of commits. Releases ship daily. 1,453 of this year's 1,800 commits landed in the last 12 weeks. 225,000 lines of Rust across 26 crates, 3,500 test functions. And unlike plenty of projects I've looked at, continuous integration actually runs them. Relay end-to-end suites, Flutter, the desktop app, and a dependency policy gate. I went looking for the usual gap between a repository full of policy files and a pipeline that enforces none of them, and I didn't find it. Quick word on how I check these because it matters for whether you should believe any of it. The project runs in a throwaway container, never on my own machine, and I never handed an account or a key. A review doesn't need to log into anything. Every claim comes from reading the source, and each one is cited to a file and a line number so you can check it yourself. Several things I was sure were bugs weren't. Once I read the code around them and those got dropped. I'll come back to a few of those at the end. Here's the shape of it. A client connects over WebSocket, the relay binds that connection to a community, events land in postgres, and subscriptions fan back out. Agents enter through the same door as people, and this is what caused the 404. The relay resolves which community you're talking to from the connection's host header, before any handler sees tenant data. An unmapped host fails closed and never guesses. That is exactly right. It's the multi-tenant isolation people usually bolt on after an incident. The fresh install ships with the domain set to buzz.example.com, so localhost hits a relay correctly refusing to guess. 2 lines in the deployment guide fix it. Now the finding I'd actually want the maintainers to see. The events table is partitioned by month, good instinct for an append-only log. The initial schema creates partitions through June and then one more. From July the 1st to max value, every future month forever in a single partition. There's a partition manager that runs at boot and tries to create next month's partition. Postgres refuses because the catch-all already covers that range. The manager catches precisely that error and carries on. And I want to be careful here because my first read was that swallowing the error is the bug. It isn't. The comment is right, the range is covered. writes are safe, and failing startup would be worse. The problem is one level up in the schema. Because the upper bound is max value, the manager can never create a single monthly partition on any schema built from that migration. The design is monthly partitioning. The reality is one unbounded table with 10 indexes and 5 insert triggers on it. No pruning and no retention. And searching the entire repository for a detach, a split, or a drop of one of those partitions returns nothing. There's no path back. Second finding. The order messages appear in a channel as a timestamp the client signs, and the relay accepts anything within 15 minutes of now. It stores that value verbatim and sorts by it. There is a server-side received at column on every row, and it is never used for ordering, which is notable because the authentication code in the same codebase uses a 60-second window. It knows how to be strict. So a client can post a message dated 15 minutes from now and sit at the top of the channel. Worse, for replaceable events, that same client-asserted number decides which version wins, so a future dated write beats every honest write, including the author's own correction, for a quarter of an hour. Third finding, and this one is a design tension rather than a mistake, every user-facing delete is a soft delete. Media blobs have no delete verb at all. The audit log has no delete path by construction. And that's the point, the admin plane is read-only. The operator command line can't touch an event. There's no HTTP delete anywhere in the relay. Nobody can quietly rewrite history, including the person who has to answer a right to erasure request. I searched the repository for GDPR, erasure, data subject, delete account, and CCPA. 0 hits. Meanwhile, there is a configuration variable for serving a privacy policy, so the relay can host a policy it has no mechanism to honor. For a self-hosted workspace aimed at teams, that is the gap a legal review will find first. One more, and it only shows up if you read both. The architecture document states plainly that no Redis-backed rate limiter exists anywhere in the codebase, and that rate limiting is not enforced. The connection handler puts events, queries, and counts behind exactly that limiter, and a Redis error becomes a client-visible rejection. The largest availability dependency in the system is one the documentation says isn't there, and a smaller one in the same family. Deletion requests, NIP9 in Nostr terms, are fully implemented with an author-only validator. But 9 isn't in the list of supported NIPs the relay advertises, so any client that feature detects will conclude this relay can't delete and won't offer it. And in fairness, 4 things I flagged turned out to be wrong on a closer read. A code comment says no index covers a particular sort to do. The architecture document describes a linear scan for global subscriptions, but the code has dedicated indexes, so the docs understate it. I've mentioned the swallowed error. Reading this codebase, the pattern is a team moving fast enough that the prose lags the code, not one cutting corners in the code. So who is this for? Reach for it if you want agents as real members of a workspace you host yourself, with an audit trail you can actually query, and you're comfortable operating postgres. Wait if you need a right to erasure path, or hard deletion of uploaded media, or message ordering you can trust against a client that lies. Or if an events table that can only ever be one partition is a problem you don't want. The honest summary is that this is an unusually well-built piece of software with an unbounded table in the middle of it. The partitioning, the 50-minute clock, and the erasure gap are all fixable, and none of them are the kind of mistake that suggests the rest is shaky. The rest is good. Every claim here is cited to a file and a line. They're all in the description, and I checked each one against the source myself. If I've got something wrong, say so and I'll pin the correction.